All right, let's try a little thought experiment. Quick, what's water? It's liquid. What's ice? It's solid. We have known this our entire lives, right? It's probably the very first science lesson any of us ever got.
And the basic rule is super straightforward. To make solid ice, things have to get cold. To get liquid water, you need some warmth. It's about as fundamental as it gets.
Well, get ready to rethink basically everything you thought you knew about the most common stuff on Earth, because that simple fundamental rule, it just got completely broken.
That is not a typo. Solid ice, at room temperature, no freezer required. And this isn't science fiction, folks. This is a brand new discovery that's turning our whole understanding of water on its head.
The thing is, water has always been a complete weirdo. Seriously, forget what you learned in ninth grade. It expands when it freezes, which is bizarre, by the way, and as it turns out, the simple ice cubes in your freezer are just the tip of the iceberg. Literally.
See, scientists have known for a while that ice isn't just one thing. There are more than 20 different known forms or phases of ice. Each one gets its own Roman numeral, and every single one has its own unique way its molecules are arranged.
The best way to picture it is like this. All these different ices are made of the same Lego blocks, good old H2O. But depending on the temperature, and really importantly, the pressure, those exact same blocks can snap together into totally different crystal patterns.
So the big question is, how on earth do you find a new kind of ice that forms when it's warm? Well, you need two pretty amazing things: an absolutely insane amount of pressure and a laser powerful enough to watch atoms move around in real time. First up, the pressure. For that, scientists use something called a diamond anvil cell. And yep, it is exactly as cool as it sounds. They trap a tiny, tiny drop of water between the tips of two perfect diamonds, and then they squeeze really, really hard. And when I say hard, I mean pressures of about 1.6 gigapascals. To put that in perspective for you, that's almost 16,000 times the normal air pressure we feel every day. It's like taking the crushing pressure at the bottom of 100 oceans and focusing it all down on one microscopic point. So here's how it goes down. They trap the water, they squeeze it with the diamonds, and while it's under all that pressure, they blast it with these unbelievably short X-ray pulses. This laser is basically a high-speed camera for molecules, taking snapshots of the action in just microseconds. They ran this cycle more than 1,000 times, letting them watch, in real time, as the water molecules were forced to rearrange themselves. And right in the middle of all that squeezing and blasting, watching water freeze and then melt at room temperature over and over again, something completely unexpected happened. As they rapidly compressed the water, pushing it into this super compressed liquid state, the molecules didn't arrange themselves into any of the known ice structures. They did something totally new.
They snapped into a brand new, never-before-seen crystal arrangement. Scientists officially named it Ice X21. That's Ice 21. It has this unique tetragonal structure, and it's what's called metastable. That's just a fancy way of saying it's a temporary, unstable state that can only exist for a moment under these very specific, high-pressure conditions. It's a whole new state of matter for water.
So let's just compare. The ice in your drink, that's Ice I. It forms when it's cold, it has a stable hexagonal structure, and it sticks around. But this Ice 21 is a totally different beast. It forms at room temperature, but only under that extreme pressure. Its structure is tetragonal, and it's metastable, a fleeting state that vanishes the instant you release the pressure.
But the discovery of Ice 21 was only part of the story. The experiment also revealed that under these conditions, water doesn't just have one way to freeze and melt. It's like it has a whole menu of options.
What the scientists found was this surprisingly complex dance. At room temperature, just by changing how fast they squeezed the water, it could take multiple different paths to become solid. It might form a known phase, like Ice 6 or Ice 7. Or it could take these other, more complex routes, temporarily snapping into the new Ice 21 structure before settling into something else. It's not one single process, but a bunch of competing pathways.
And that's really the magic of that X-ray laser. Without it, you'd never see this. These transformations, these different types of ice can pop into existence and then vanish in just millionths of a second. It's this hidden, high-speed dance that water is doing all the time when you put it under pressure.
Okay, so I know you won't be making room temperature ice cubes for your drink anytime soon. But this discovery isn't just some neat lab trick. It actually has massive implications for physics, chemistry, and even astronomy.
This gives us a much better model for what might be happening deep inside those so-called water worlds, like Jupiter's moon Europa.
Down in their cores, under immense pressure, water could be forming these exact types of exotic, hot ice. It also forces us to rethink the basic rules of how things change state. It proves that the speed of change can be just as important as temperature and pressure.
And this could just be the beginning. As one of the researchers, Rachel Husband, put it, this discovery suggests there could be even more of these weird, high-temperature ice phases out there, just waiting to be found. We've just opened a new door. It's just incredible when you stop and think about it. We are surrounded by water. Our own bodies are mostly water. It is the most familiar molecule in our entire lives. And yet, it continues to completely surprise us. It holds these deep secrets that we can only unlock by pushing it to the absolute extremes with things like diamonds and the world's most powerful X-ray lasers.
It makes you wonder, doesn't it? If water, something we thought we knew inside and out, can do all this, what other seemingly simple substances out there are hiding their own mind-bending secrets, just waiting for us to squeeze them hard enough?